Hi, in the last video I talked about functions. I explained what a function was and I gave a couple of examples. We talked about this linear function and this quadratic function here. Okay, in this video I want to talk about plotting functions. So let's start off with this linear function here. I'm just going to make a little box here. So we had this function here. It was a linear function. And we put in this value 0, 1, and 2, and then we got out these three outputs, and we put this input-output pair into brackets like this. Okay, so we have a bunch of numbers, this 0, 1, and 2 output, and this 3, 5, and 7, sorry, this 0, 1, and 2 input, and this 3, 5, and 7 output. And what I want to do first of all is just to represent these numbers. I want to make two different number lines, so I make the first number line like this, okay, I make the second number like this, okay. So this first number line here, I'm going to say is for the input. So these are these input numbers for these x numbers, 0, 1, and 2. And then the second number line is for the output numbers, f of x. Okay, now if I go ahead and plot these numbers, so 0, 1, and 2 are the three inputs. And then here, I know there's no 0, but I always put a 0 on the number line, just to be clear. Okay, here's our three inputs and our three outputs. So what I've done is I've taken my three inputs and my three outputs and put them onto two parallel number lines. Okay, so now the problem with doing this, so this is fine if we just want to represent the input and output numbers on the number line, but the problem with doing this is that we don't know which one corresponds to it. We don't know that 0 corresponds to 3, that 1 corresponds to 5. It could be the other way around, right? So the best way to do this is to actually draw our number lines perpendicular to each other. Often this is called an XY axis. So let's say that the vertical number line here, this is for the f of x numbers, and the horizontal number line is for the x numbers, okay? And then we put in, and when you make these, when you put these two number lines perpendicular to one another, you just make sure that they cross over at 0. So this 0 is the same for each one. Okay, now I'll put down the ticks on the axis. So there's our 3, our 5, and our 7. And it's very simple what we do. What we do is, let's say, okay, let's take our three inputs. These are our three inputs, 0, 1, and 2. Here is our three outputs. And just like you would on a map, on a sort of a grid reference, let's say for this 1, 5 pair, you go along to 1 on the x-axis, and then you go up until you hit a 5 here, okay? And then you go for this 2, 7 pair, you go to the 2, and then you go up here, and then for the 0, 3, you go to 0 on the. So you always go to the point on the x-axis where the input number is, and then you go up or down vertically depending on whatever number is there. So this is the third one. So these are we call these points. So these are, we think about now these as being points in this 2D XY axis here. Okay. Now, once we have the 3 points, there's a couple of things that we can say. What we see here is that the output number goes up in an even step each time. So if we put an f of 3, if we put 3 into this function, we'll get a 9 out here. Then we'll get 11, and then so it always goes up evenly. Like for every step 1 we go across, we go 2 up. We go 1 across, we go 2 up. And what that means is that we can actually put in all of these points. We can imagine where they would be, right? And if we were to do all of the ones in between as well, they would fit exactly along like this, along this line like this. Okay, so we can then connect them all like so. Okay, now what that means is the following. So let's say, for example, we had an input number, this number here, right? And we wanted to have an idea what the output would be. So we've actually calculated, these three examples. We've calculated these three over here, okay? Well, let's say we wanted to take a new one, this one here. Well, what we can do is we can go up until we hit the line, and then we can go across, and then we can actually say, well, if we put in a number between 1 and 2, our answer that we get out is between 5 and 7. Or we could say, for example, we could put a number between 0 and 1 in, and then we get an answer between 3 and 5. So let's try that one. Let's say for example we did f of a half. Okay, so f of a half would be 2 times a half plus a 3. Now 2 halves, well that's just 1, so then 1 plus a 3, that's a 4. So then you get out the point a half and 4. So I said if we put in a number between 0 and 1, which is a half, we get out a number, an example of a number between 0 and 1 is a half. If you put in a number between 0 and 1, then you get out a number between 3 and 5. We got out this 4 as our answer. So the graph is very useful to us if we wanted to sort of predict what an input-output pair was going to. So we'd say if we put this number in, what number would we get out? The other thing that we can see from this graph is this is a straight line that will go up and up and up and up forever. And it will also, if we were to follow the number back in this direction here, it would also go down forever. So we can see this sort of like, global pattern. We understand what's happening for all of the function once we make this kind of plot. Okay? Now the easiest things to plot are straight lines. It's slightly harder to plot quadratic equations. So let's have a look at this example here on the next page. Okay, so again, I want to just make a box off of this here. Okay, so these will be our points that we put in, and this was the function that we were using here. Okay, so first of all, I want to put these 3 points on an xy axis. So let's draw our axis. Here we have f of x axis. Here we have the x-axis. Okay, that's the 0 for both the f of x. They cross over at 0. Let's make this a 1 and a 2. I'm going to put some more 3, 4, 5 up here in a minute, so that's why I'm leaving some space. And the numbers we get out are 0, 2, and 6. So let's go up in steps of 2. So let's say that's a 2. And then the same distance again will be a 4. And then we're up here at a 6. Okay. Okay, so our 3 input numbers, 0, 1, and 2. Let's mark them there like that. 0, 1, and 2. And our 3 output numbers, 0, and 2, and 6. These were our 3 output numbers. And how does it go? Okay, well, 0 and 6 is the first one. So 0 input, go along the x-axis until we find a 0, and then go up as far as 6. Okay, that's the first point. Okay, and the next one, okay, 1 and 2, that's the second point. Okay, and the third point is 2 and 0. Okay. Now, something interesting is happening here. The interesting thing that's happening is that this is not, if we wanted to make a straight line with these two, you see this one here, this third point, that's not going to be on the same straight line as this. So what that means is that these 3 points, they're not what's called collinear. They're not collinear. They're not collinear, meaning that they're not on the same line. Okay, so that means that whatever we draw for these is not going to be a straight line. It's going to be some kind of curve. Okay, so let's just get rid of those straight lines. So whatever we draw here it'll be some kind of curve. Now the question is, well, what kind of curve is it? I mean, is it something that curves and then just sort of keeps on kind of going down, but with a little bit of a curve, or is it? It could be something that, like, curves down, but then maybe it curves back up again or something like that, right? So as we are with these 3 points, we're actually not able to say. So what we need is a little bit more information. Okay. Now this list that I'm going to do, it's not endless. We actually just need to work out 3 more points. And after finding the roots, which will be in the next video, we'll know where to start, what number to start with, and what number to end with. So that will help us. And I'll explain that in the next video. So we just need to work out 3 more points. So the first one, f of 3. Okay, well, this is the function. Anywhere where you see x now, we're going to replace it with 3. So we have 3 squared minus 5 times 3 plus a 6, which is going to be the same as 9 minus a 15 plus a 6, which is equal to 0. So that means if we put in a 3, we get back out a 0 again. Okay, so let's mark that point. So there's our 3, and here is our 0. Okay, so that gives us an idea. So our curve is going to actually, it's going to have to come back up to that 0 there again. Okay, so let's put another point and we'll see. And we'll also see a pattern happening with our outputs. So f of 4, so we go to a function. Anywhere we see x, we put a 4. So that's 4 squared minus 5 times a 4 plus a 6. So this becomes 16 minus 20 plus a 6. And now 6 plus 16 is 22, and 22 minus 20 is equal to 2. So this is then 4, 2. Okay, and the last one, f of 5. Okay, well, f of 5 is going to be equal to 5 squared minus 5 times 5, and then plus a 6. And then the thing that we see here is 5 squared. Well, 5 times 5 is just 5 squared. So that means that this is 5 squared minus 5 squared plus a 6. So those two would cancel, and we're just left with the 6. So we get 5, 6 as our answer. So let's just continue this line on here. Okay, so these are the points that we have to put in. So let's put in the 4 value first of all. There's a 4, and then we go up to a 2. That's our 4, 2. And then the last one, well, let's make this a 5. We'll just extend that out a bit. Call that x. There's our 5 value, and then we go up as far as 6. Okay? So now let's have a look at our input. So here are our input numbers 0, 1, 2, 3, 4, and 5. So they count up by 1 each time. Let's see if we can spot a pattern for our output numbers. So 6 to 0, and then 0 to 6. So you see actually they copy themselves. This counts down 6 to 0. This one counts up 0 to 6. Okay? So what does that mean? So let's go ahead and make a... Now we can go ahead and we can fit a curve to these points. So we can start to draw a curve and fit the curve to these points. So, so we go like this. Okay, a little bit uneven, but okay. So the first thing that we realize here is that this curve here, this curve, imagine this is this green dashed line I'm drawing here. This is a mirror. Imagine that's a mirror. And this is perfectly reflected on both sides. So whatever values that you get here, you get them copied on the other side. So that's why you have this 620, 026 happening. Okay? Okay, the second thing to realize is that this function here, okay, well, just another point, as we said before, so if we want to guess, well, what happens when we put a half in? Well, we can start at a half and we can go up and we can say, well, our answer for a half, that should be between 2 and 4, for example. We can kind of see what's happening in between the numbers that in between these values that we put in. We can use the graph to have an idea of of what our output's going to be. Okay, for those values. Okay, the next thing to realize is that this tail of the function here, this goes up forever. This tail goes up, goes up forever here, and this tail, it goes up forever here. Okay, on this side. So both the tails go up forever. Okay, but this function here has a minimum value. It has a value that it never goes below. Okay, now if we were to look at our last example, there wasn't any minimum value. This thing just went down forever, and it went down forever when we went back this way, and it went up forever when we went in the other direction. Okay, so here we can see with this function that actually it has a minimum value, that it never goes below whatever this is here on the f of x axis here. Okay, so those two examples there, linear and quadratic functions, plotting those linear and quadratic functions, we can kind of we can see the benefit of making a plot. Making the plot gives you an idea of the global behavior. You know, for example, here it'll go up forever here, it'll go up forever here. It's always a curve. It's symmetric. We can get this understanding of this sort of global behavior of the function from the plot. from this example, we could see that it goes up forever, it goes down forever. It always has the same slope. It never curves. It never curves up or curves down or anything like that. Okay. Now, in the next video, I'm going to talk about finding roots, and we'll see that by finding roots will help you sometimes to make a plot of the function and to choose which input values you're going to put in for your function.